You will learn how to configure an AKS cluster with an HTTP proxy so that the egress traffic coming from the nodes and from the pods will be routed through the proxy server. We have seen that we can do actually a similar configuration using the UDR outbound mode in Kubernetes, where we can create an AKS cluster that uses the UDR mode for the outbound type, and that will force the traffic to be routed through an MVA or a firewall when we use a route table that will route all the egress traffic to the firewall IP address, and from the firewall the traffic will go through the public IP address to the internet. Here we can achieve the same thing but without using an MVA or a firewall, but with using an HTTP proxy server. With this feature in AKS, we can force the egress traffic from the pods and from the nodes to go directly to the HTTP proxy server and then to the internet by using the public IP address of the proxy server. So note that with the proxy configuration, the configuration actually will be applied to the pods and to the nodes of the cluster, not to the subnet of the cluster like with the UDR mode. And with the HTTP proxy, all egress traffic will be routed through the HTTP proxy server by default, but you can create an exception where some pods will have their egress traffic going through the load balancer public IP address. Let's see how that works in an AKS cluster. So typically you will need to create a JSON file that contains the configuration for the proxy, and this contains the HTTP proxy IP address and port number, the HTTPS proxy IP and port number, and in the no proxy block right here we mention the IP address and the localhost and the CIDR ranges that should not be proxied. Here I'm adding docker.io and docker.com as an example to this list. The important stuff here is to put the public IP or the private IP address of the proxy server if it's in the same network, and then you put also the trusted certificate authority. With that configuration, describe it into a JSON file. You can create a new cluster with that configuration. Note that here you cannot enable this configuration for an existing cluster that doesn't support HTTP proxy. Once that configuration is applied, now if we run an nginx pod, for example, from there we can see some environment variables that were injected that contains the values from the JSON file. So we see here the HTTP proxy private IP address, the list that we have put on the no proxy, and note here there are also some additional values that were injected by the platform itself, by AKS itself. Those are needed and necessary for the functioning of the cluster. So then from inside the pod, if I exec inside and run curl ifconf.me, that service that will give me my IP, the IP address that it sees. So here the pod will egress to the internet through the public IP address of the proxy. So by default, all the traffic will go through the public IP address of that proxy, but you can create an exception if you have some pods or deployments that should not go through the proxy. Then you can use the annotation kubernetes azure.com/no HTTP proxy vars equal true, and with that you can see that the proxy will connect to the internet through a public IP address of the AKS load balancer. Now once the HTTP proxy configuration in AKS is created, you can update it. So you can update the variables like the HTTP and HTTPS proxy, the no proxy values, and the CA certificate. But here pay attention to the following. So the new values for the environment variables will not be applied immediately into the pods and the nodes. So for the pods, you will need to rotate your pods. You need to redeploy it, delete it and redeploy it. And for the internal Kubernetes components like the containerd and the node itself, here you will need to perform a node image upgrade, because those environment variables will not take effect until you restart those workloads. Follow me next to work on a demonstration where we have an AKS cluster with the proxy configurations that will route the traffic to an HTTP proxy server to route the egress traffic to the internet through the IP address of that proxy. In this demonstration, you will learn how to configure an AKS cluster with an HTTP proxy. For that, we'll create, using Terraform, the following environment. We would have an AKS cluster that contains pods and nodes, and then we'll go to configure the proxy settings so that it will route the egress traffic to the HTTP proxy server, And after that, we can see how we can create an exception for a pod that will not go through the proxy, but it will go through the load balancer public IP address to connect to the internet. The source code for this Terraform is available on this GitHub repository under the folder 67 egress proxy, where here you can find the documentation within the README file about the architecture, the different commands, and the steps that we need to perform. So let's go through this lab one by one. So the main configuration in this lab is this JSON file that contains the HTTP and HTTPS proxy IP address and port number, and the no proxy configuration and the trusted CA. We'll go back to this at a moment. So let's start first by creating a new proxy server. So for that, we'll be using a sample proxy like mitm-proxy, men in the middle proxy. To create it, actually, I'll go to install it into an Azure virtual machine. So within this file, I create an Azure virtual machine that have a public IP address, a network interface attached to a subnet within a virtual network. And then in the virtual machine right here, I create the VM, and inside that VM, I run a shell script that is install mitm.sh, which is this file here. So this file will start first by getting the mitm-proxy downloaded into the VM and then unzip it using tar xvf, and then before starting the mitm-proxy server, we have two options. Either we use the generated certificate. When mitm-proxy starts, it will generate a new certificate. We can use that one. But in this demonstration, we want to use our own certificate. So for that, I've created a certificate and I've uploaded it into my Git repository. So here you'll find those links for these certificates. And to create your own certificate, you can do that by following the instructions from the certificate folder right here. So where we have the generate cert sh file. So first of all, you will need to use OpenSSL in order to generate certificate key, and then generate the .pem file, and then concatenate the key and the PEM file into a .pem file that is required by mitm-proxy. After that, I go ahead to create a certificate that could be used optionally for connecting from a Windows machine that is a format .12. And then next I use this command cat cert.pim, output the content as base64 so that I can use this value for the JSON configuration for the HTTP proxy. So we take the CA certificate and then encode it using base64 and pass it to the JSON file, and that is the content of this value right here, the trusted certificate. And after that, at the end, so we get those three certificates, and then we start the mitm-proxy. Here I start the web application, and also I start at the same time the mitm-proxy. I'll expose the proxy under the port number 8080 and the web app under the port number 8081. And then I use the certificates that I have imported into this current folder. So with this configuration, I would have my Azure virtual machine running the mitm-proxy. So for that, if I go to the Azure portal to the resource group created for that, I can see right here the virtual machine, and I can see the private IP address and the public IP address of this VM. So if I open it, and then if I navigate to port number 8081, I should be able to access here the web app for mitm-proxy. And from here, you can see some of the requests that passed through the proxy. And for each one, I can see the timing, the response, the connections. And then we can see here in particular the ifconf.me, the web server that will give the IP address that it sees from the client. And we'll go to this in a second. So now we have the HTTP proxy server already running. Now let's go to configure our AKS cluster to use this HTTP proxy. So I can do that either using the Azure command line, the Azure CLI, or I can also use Terraform to do that configuration. If I also use the command line, then I will need this JSON file to pass it through the command line using the command az-update, az-aks-update, and then pass the values from here. Here I want to use Terraform, so with Terraform, when I create the AKS cluster, I would have a block called HTTP Proxy config, and from here I'll put the values for the HTTP proxy, HTTPS, no proxy, and the trusted certificate. It have almost the same structure as the JSON file. So I put the same values right here, not here, of course, as I'm using Terraform, so I'll use the variables and the Terraform resources. So here I take actually the private IP address of the network interface card from the virtual machine as the IP address for the proxy. So note here in terms of networking, the AKS cluster sits in its own virtual network, and also the virtual machine for the proxy have its own virtual network. And we have established peering between the two virtual networks. So this way, the AKS cluster can reach the HTTP proxy server. Now with this configuration, we can check from the AKS cluster if you go to the Azure portal, and then if you go navigate to the JSON view, select the latest API version, and then look for HTTP proxy. From within HTTP proxy config, you will see the config that we have passed, and here you can see the private IP address of the virtual machine that is running the proxy and the no proxy value. And note here we have passed only the localhost Docker IO127 docker.com, but AKS actually injected some additional values that are needed for the functioning of the cluster. So it injected the connectivity, the side ranges for the IP addresses for IMDS, and also the FQDN for the AKS control plane. And below we can see the trusted certificate, the one that we have injected, which is encoded in base 64. Of course, here don't forget to create the NSG to open up for the web app, and associate that NSG to the subnet of the virtual machine. Great, so now once we have deployed all this Terraform configuration using Terraform init and Terraform apply right here, we should have our cluster running, and if I run get nodes, we should get the nodes of the cluster. And now I'll try to run or create a new nginx pod, and from that nginx pod I'll go to exec and run the command curl ifconf to give me the IP address that it see from that pod. If I run that command, here I see this public IP address 104.40, which should be the public IP address of the Azure virtual machine as we see it right here. So the proxy settings will be applied for the pods and also for the nodes. Let's check for the nodes. So let's try to go to debug a node or attach an SSH session. I'll take one of my nodes, let's say the first node for example, and access into that node using an Ubuntu image. And from there I'll use chroot /host to access into the node. And here if I run env to show the environment variables, we should see that there are some environment variables for the HTTP proxy settings, where we see HTTPS proxy, no proxy settings, HTTP proxy, and HTTPS proxy. And note here for each environment variable, it's written twice, once in lowercase and once in uppercase. Great, so this HTTP proxy settings injected those environment variables into the nodes and also into the pods. So if I try to exit here to go back to the AKS cluster, if I try right here to do kube control exec into the pod and run env in order to show the environment variables from the nginx pod, we should see here the same environment variables were injected into the pod. Great, now what if I want one pod to not go through the HTTP proxy settings? So I can do that through the annotation kubernetes.azure.com no HTTP proxy vars equal to true. With this annotation, the environment variables will not be injected into the pod, and thus the pod will not go through the HTTP proxy server. Let's try that. So here I go to apply my pod using kubecontrol apply, then the name of the YAML file, and then I go to run exec into the nginx no proxy, and then I'll go to run ifconf.me, and from there I can see here another public IP address, which is the public IP address of the AKS load balancer. And I can check that if I go search for the resource groups, and then within the AKS node resource group I can see a value right here, which is the public IP address of the cluster, and that is for .245, which is the same IP right here. So that was because if I run env inside that pod, I should see that here there is no environment variables injected for the HTTP proxy. I hope this was helpful. Thank you.